Hello everyone! Today we are going to share some knowledge about scatter plots. Firstly, we need a two-dimensional coordinate plane with the x-axis and y-axis representing two variables. We plot each data point from the dataset in this coordinate system, and then we can analyze the data based on the features observed in the scatter plot. If the data points are clustered and have an upward trend, it indicates a positive correlation between the two variables. If the data points are clustered and have a downward trend, it indicates a negative correlation between the two variables. If the data points are randomly distributed without any specific pattern, it suggests no correlation between the variables. Next, we can add a trend line to the scatter plot to describe the overall trend between the two variables. For example, in a positive correlation scatter plot, we can draw a straight upward line. And in a negative correlation scatter plot, we can draw a straight downward line. There can also be other types of trend lines based on different relationships, such as inverse proportion. The trend line helps us better predict the data. To draw a trend line, we need to find the best fitting line that accurately describes the overall trend of the data. To draw a trend line, we need to find the best fitting line that accurately describes the overall trend of the data. Based on the equation of the best fitting line, we can make predictions for the data, where the y-intercept represents the initial value and the slope represents the rate of data change. For the first question, to find the most suitable quadratic model from the given data, we need to identify the best fitting line by drawing a line that represents the overall trend of the data among the data points. We then select the closest data point to 1 and substitute it into each equation given. It appears that only option D satisfies the equation condition. In the second question, we are asked how many data points in the scatter plot have predicted values greater than the actual values. To determine this, we need to understand that predicted values refer to the points on the best fitting line, while actual values are the corresponding values for each data point on the scatter plot. To find the data points with predicted values greater than the actual values, we need to locate the points that lie below the line. These points have actual values smaller than the predicted values. In total, there are 1, 2, 3, 4, and 5, a total of 5 points with actual values smaller than their predicted values. In the third question, the best fitting line predicts the average price per square foot to be $76 in 2001. And the corresponding predicted point lies here. We are required to determine the difference between the predicted value and the actual average value per square foot in 2001. Based on the given information, we can see that the actual value at the corresponding point is 72. Therefore, the difference between the predicted value and the actual value is 4. Hence, the correct answer for this question is option C. Bye.